PowerShell scripting, looping constructs. This has nothing to do with roller coasters. These are the scripting language elements that allow PowerShell to repeat a certain action either a certain number of times or based on some criteria that you set up. We've got three constructs for you and some seasonal variations. We'll start with the for each construct, used to enumerate through the objects in a collection. Then we'll look at the for construct, which is really just a loop that's designed to repeat a predictable number of times. And then we'll look at the one that has the variations, the while, until, and do keywords. You kind of use these off in pairs. You'll either use do or you'll use while, but how you use them kind of depends on the exact functionality that you're looking for in your sequence of execution. Now, as in the previous nugget, everything I'm going to be showing you here will work just fine in PowerShell version 2, PowerShell version 3, whatever you're working in. I'm just going to be working in PowerShell version 3 because I like the ISE just a little bit better in this version. So let's get started with our first loop. I'm going to begin with a loop called for each. Now this is a lot like the for each object commandlet. And it's so much like it, in fact, that I'm going to do both of these kind of side by side so that you can see them both. Just for fun, let's get a couple copies of Notepad running. This will be a good thing for us to play with. Now here in the console, I can run a get process, name, Notepad, pipe it to GM, get member, and I can see all of its properties, and I'm really after methods right here. So we've got a method called kill. Now that should kill it. So what I want to do is do that over here in script form. Get process, name Notepad, pipe to for each object, and then in its little script block, $_.kill. Always putting those two parentheses after the method name. Now this is the version 2 and later syntax. In version 3 and later, instead of the underscore, you can put PS item if you prefer. We'll stick with this. So that's completely valid code. That will use get process to retrieve every instance of a process named Notepad, and then for each one of those, it will execute this kill method. Now this is not necessarily the most efficient way to do this. And the reason is it kind of ties into how the pipeline works. What's happening is it's taking one process object at a time, putting it into the pipeline, and sending it to for each object. Every single one of those requires PowerShell to parse and execute this script block. Now, we're doing, what did I do? 2 copies of Notepad? We're doing 2 things. This is not a big deal. Point is, though, if you get into the hundreds of things, this becomes a big deal. Let's do this. Actually, we'll put this up here because I think this is something I might run a few times. I'm going to use the range operator to create 100 copies of Notepad and hope that this doesn't crash my computer. So we're going to pick this and hit F8 to run just the highlighted bit. This is probably a horrible idea. Okay, we'll see how it does there, but it's got a lot of them. So this is obviously going to kill them all, but let's measure it. Let's actually see how long it takes it. Measure command, script block or command. Actually, we'll just put it in brackets. There we go. Right, so these are now being measured. It's still going to actually execute this, but we should get a result on how long it took. So let's execute this now. Pretty quick, took 24 milliseconds. I'm just going to make a note of that. 24 milliseconds. So that's one way of doing this. I'm going to take the measure command wrapper off of here so we can just kind of consider this little thing all by itself. There is a scripting construct also called for each, and it works completely differently. PowerShell figures out which one you're using based on how the actual command line is built, and it looks something like this. Processes, I'm going to get these things and put them into a variable. Get process, name Notepad. For each proc in processes. So here's how this works. The in keyword inside these parentheses is mandatory. That's part of this syntax. You'll notice that the color coding for this for each is different than the color coding on this one. This is not a command, and I am not piping anything to it. It's a scripting construct. So inside the parentheses, after the keyword in, I give it a variable that contains one or more objects. You see, this one conveniently contains one or more objects because I've used a command to retrieve one or more processes. It's going to execute whatever is in this script block once for each thing that's in here. Each time through, it's going to take one object out of here and stick it in here. This proc variable I get to completely make up on the fly. Now, you'll notice that I have kind of chosen a variable name that reminds me this contains multiple processes, this only contains one process, or proc. You don't have to do that. There's no magic. PowerShell's not looking for the names to match up. You know what? In fact, just to make that clear, let's do that. I just made this variable up completely. The purpose of this command is to take one thing out of here, stick it in here, and then I can use this inside my script block. Now, in this case, I know, because I wrote the code, that Fred will contain a process object, and I know that process objects have a kill method. This is equivalent functionally to this. This second one does not use a pipeline, though. And why is that such a big deal? Well, a couple of reasons. For one, $_ is not the easiest thing to read. You have to kind of backtrace. How do I know this is a process? Well, because this got process and piped it in here, and this represents whatever was piped in. So you have to make a little bit of a cognitive leap to make that all make sense. More importantly, if I needed to start nesting several things, for example, if Fred VM is greater than 10, then Fred kill. So once you start nesting constructs like this, this syntax starts to really work against you. If you want to do multiple different things in here, jamming it all together into a pipeline like this starts to work against you a little bit. So I'm going to take this out because I actually want to do a one-to-one comparison on the performance. Before, I started up a couple of copies of Notepad manually. So I'll go ahead and do that again. Then I ran this. F8. It's going to get a lot of copies of Notepad up and running. And now let's put a measure command and just measure this version. F8. Took about 19 milliseconds. Now that was to process 100 objects, so that was a 5 millisecond savings across those 100 objects. So I guess we could say that's a 20th of a millisecond per object. The point is, these two versions did exactly the same functional thing. This one ran a little faster, and that performance savings will become magnified the more complicated your script block is, and the more you have to repeat it across a large number of objects. So while this approach is something that you might just bang out in the console, typing it manually, this approach is a little bit more structured, and it's something that you're going to want to sort of focus on as you pull things into a script. They both get the job done. One of them is a little faster and a little bit more flexible and a little bit more structured. The pipeline tends to be good when you're just knocking something out at the console real quickly, manually. This type of looped approach, structural constructs, tends to be more effective when you start moving into a script. All right, so that is the for each construct. Let's clear things out and set up for the next one. So our next construct is the for construct, and I actually have a little script I put together. Let's walk through this. I'm starting by creating an array of strings. So this is the index 0, index 1, index 2, index 3, and index 4. meaning the index numbers I use to refer to each of these individual elements. In other words, I'm going to copy this to the clipboard. Let's paste it over here in the console. You can see that array 1 contains those items, and using square brackets, I can get to individual items, with 0 being the first. I can also access its total number of items. Now, this is a little bit tricky. It says there are 5 items, and that's totally true, but you can't access anything from the 5th item because it starts at 0. So technically, the last item in the array here is index 4. So you get 0, 1, 2, 3, and 4. All right? Array 2 is another array of 5 different strings. And then I've got this string that says, one day we saw 2 eating 4. Okay, here's the actual loop. A for loop has a script block, and this is the body of the loop. This is what will happen every time we execute the loop. In parentheses, there are 3 elements separated by semicolons. The first element sets a starting condition. This will be executed before the loop executes itself for the first time. I'm simply creating a variable x, defining it as an integer, and setting it to the value 0. The last element gets executed after the loop completes each time. X++ will increment whatever value is in x by 1. So essentially, I'm starting with x equal to 0, and at the end of the loop, it'll be 1, and then 2, and then 3. The middle element tells the loop when to keep repeating. So long as this expression evaluates to true, then the loop will execute again. I'm saying I want you to keep executing so long as the contents of x is less than array 1's count property. So hopefully this will execute 5 times, and x will contain values 0 through 4. Now what am I doing with it? Well, I'm taking my string, whatever was in there, so it's starting off as this, remember. I'm using the replace operator. I'm looking for all instances of the x index of array 1. So the first time through the loop, this will be index 0. The second time through the loop, it'll be index 1, and so on. So I'm going to look for that in here, and I'm going to replace it with the corresponding element from array 2. So let's just run it. Fred Day, we saw Barney eating Betty. Probably be better if he had Cocoa Crispy Pebbles or something like that. So the idea here is that we've taken elements from this array and replaced them with elements from this array. Now, where can you use that more production-wise? Well, let's say you've got a bunch of strings, and I'm going to make a second array here, and we'll call it emails, actually. And let's say it's don@cbtnuggets.com, and we'll have another one, joe@gmail.com. Sorry, Joe. And we'll have fred@company.com, and so on. So we could add those up as much as we wanted to. Let's say that array 1 is a bunch of old domain names, like cbtnuggets.com, and gmail.com, and company.com. And I'm running out of room, so we'll just stick with those 3. Array 2 is our new email addresses. Let's say it's nuggetlab.com. And we're going to switch everybody from Gmail to Outlook.com. Go Microsoft. And then everybody from company.com will be switched to company.pri. We're switching to a little private domain name there, and we'll delete these other 2. Ooh, stop it. So kind of a neat little trick there. Now, here's the trickier trick. We're going to combine the for each loop now. So for each email in emails, and I'm going to open my curly bracket and go down here and close it because this entire thing is going to be nested. I'm going to get rid of that little output there, and I'm going to say email equals whatever the email was before, and we're going to run through all the possible domain names it could be and try and replace this with this, this with this, that with that, and so on. And then when we're done, I'll just have it output the new email address. Write output email. Right, so we can run this now. And it goes through and sort of intelligently replaces. Every time it finds an instance of this, it replaces it with the corresponding one from the second array. So that's a useful way to do this. And the reason we're doing for here is because we need to run through a fixed number of items. Could have done for each. The problem is we need to be accessing 2 arrays. And so by keeping track, okay, I'm on number 1 now. The fact that I know I'm on number 1 means I can get to this item and this item. So it's useful to have this x variable here because it lets me refer to both arrays kind of at the same time. Now, that said, you might not find yourself using the for construct very much, but it's certainly useful to know it's there when you need to enumerate something a specific number of times and you need to know what number of time you're on. It's certainly not the only way we could have achieved that task, but it is a good example of when you might want to use that particular construct. Now, the next loop we're going to look at, there's actually some variations on, so I'm just going to start with a fairly simple version. Let's say that you have got servers in your environment, hopefully you do, and they have names. Now, you've got a new server you need to spin up, and you need to find a free server name. So, for example, let's create a hash table. No, actually, a normal array will do. So let's say existing. And we're just going to put some server names in here. Server 1. Oops, stop that. Server. Now, I'm not going to do these sequentially, right? Server 2, we used to have one, but we retired it a while ago, and we never reused the server 2 name. So we've also got server 4 in here. We've got server 7, 5, and 6 missing for some reason. So the idea is I want to write a little loop that will look for the next available server number or server name. So we're going to start with candidate equals 1. All right. At the end of this, we want to know what the real server name is. We're going to start by looking at 1. Here's what we're going to do. A do loop. And then at the end of this, we're going to do a while. So possible name equals, in quotes, candidate preceded by the word server. And we're going to do a little trick here. We'll set this to 0. And then in here we'll do candidate plus plus. And then our loop condition will be while existing contains possible name. Only we want that to be a not. And I'll walk through the logic here in just a sec. And at the very end, possible name. Okay. So here's what we're doing. These are the names that already exist in our environment. That's in an array. I'm going to start by setting a variable candidate to 0. And then I'm going to do. Now, because there's no condition here, it doesn't say do if something is true or false. It simply says do. It means it's immediately going to drop into the loop, increment candidate by 1. So the candidate variable will now contain 1. It's going to create a possible name consisting of the word server, followed by whatever value is in the candidate variable. And then it's going to see if it wants to repeat the loop or not. And I'm telling it, repeat the loop while not existing contains possible name. Actually, I don't want that not in there. That's bad logic. In other words, if the existing array already contains our possible name, then I want you to repeat the loop. Keep repeating the loop until we come up with a name that doesn't exist in our list of existing names. So let's save this. Save it as do 1. And let's run it real quick. It came out with server 2. So it started with candidate 0. We increment candidate to 1. Possible name will now contain server 1. I want to continue looping while this array contains server 1. Well, it does. It does contain server 1. So we're going to keep looping. Now candidate equals 2. Possible name is server 2. I want you to loop while the array contains server 2. Well, the array does not contain server 2. So we're going to exit the loop and we'll just display it. So let's make this fun. Let's So, okay, we found server 2, so now we're going to update our array to contain server 2 because that's now in use, and I need to spin up a new server. Run it again. It found server 5 because it tried server 1, 2, 3, and 4 and kept repeating while the possible name was in the array. So that's a really neat use for this type of a loop. Obviously, you might, instead of building this out of an array, you might query it out of Active Directory or look in a list of server names or whatever you wanted to do. The idea is to continue repeating something until a particular condition is no longer true. Now we've got some variations on that construct. There's while, and there's also until. And actually that comes at the end. Hang on. Got to get the whole thing in there. So there's two other variations. Now this is pretty obvious. I could have used this here and said do until not contains. All until does is it switches the logic. When you use the while keyword, you'll continue executing the loop if this condition is true. If you use the until keyword, then with the while keyword, you'll continue executing while this is true. With the until keyword, you'll continue executing until this is true. So while it's false. It's all in how you build the logic. That's not really important. I don't really see a lot of people use this because you can build this logic however you want to. This is the big difference. With this one, the contents of the loop will only execute if this is true to begin with. So let's take this out. You don't really use those much. How many times, and I'll make sure this isn't an infinite loop by incrementing, how many times do you think this will print the word hello? Run it. F8. It didn't print hello at all. That's because it'll only execute the contents if this is true to begin with, and to begin with, this does not equal that, and so this never executes at all. That's different from up here. Because there's no condition on the opening statement, the contents of the loop will always execute at least once, and then it will figure out if it wants to keep executing. So just a couple of different ways you can build that. So really, 3 different types of loops. They're all basically doing the same thing, just different constructs. And in this case, where the condition comes first, you've got a little bit of a change in the execution pattern because this doesn't necessarily have to execute. So that's 3 main constructs: the for each construct, the for construct, and then all the variations that are kind of the while, the until, the do. Now again, remember the logic on these ones can really differ. If you do first, you will always execute the loop because you won't get into the condition until later. But if you do while first, then the loop will only execute if your condition is true to begin with. And because until really just reverses the logic, I don't personally see a lot of folks use it. You certainly can. It's there for a reason, but you can accomplish the same thing with while. So if you're looking to minimize the number of things you have to remember for right now, while, do, for each, you're covered. I hope this has been informative for you, and I'd like to thank you for viewing.